Good morning, folks, or good afternoon, depending on what class you're in. All right, so today's lesson, we're going to be talking about grid moves. Okay, what does that mean? Well, tune in, you'll find out. Okay, so the start of this lesson, which you should have looked through already, right, is to just notice and wonder the isometric grid. What do you notice? What do you wonder? Okay, so some common things that people tend to wonder is, what on earth is this? Why is this grid made out of triangles, which is also kind of a notice. If you notice that this grid was made out of triangles, lots of itty bitty ones, then congratulations, right? You've aced the first starter. Now, oh no. If you said that this was made of a bunch of equilateral triangles, well, you'd be even more correct, right? So each of these little triangles are equilateral triangles, which means that they are made up of, means that their sides are the same length, their angles are the same, all that good stuff. Now, the cool thing about this is that, we know that each angle is 60 degrees, right? All these little angles within this triangle. So that means all of the other little angles on here are also 60 degrees. We take two of those little angles and put them together, right? 60 plus 60 is 120 degrees, right? Perfect. And if we get three of those little angles together, we've got a straight line, which is 180 degrees. Okay, cool. We know some angle measurements. So the isometric grid allows us to kind of identify 60-degree angle changes, all right, as opposed to 90-degree angle measures in our classic grid that we have and that we'll be using lots more than we do this. This isometric grid we talk about at the beginning of the year and then at the end of the year. Exciting, right? Things come full circle. So let's move on. Great work on the isometric grid. I'm assuming y'all did great work, okay? As long as nobody said it's made up of squares, then we're all good here. Okay, now our practice problems from last night, if you want to pull that up and take a look at these, I'll go through them with you, okay? Because this is something you're supposed to do. This is something we do every day, or something I do every day with students, because in my class, you do tend to get homework most nights, right? So the next day, we always go over that homework, okay? Unless there's something really, really, really pressing, which right now, there isn't. So let's go over it, okay? Problem number one, okay? Great. Each of these 6 cards show a shape, okay? Which pair of cards shows a shape and its image after a rotation? Okay, keyword being rotation. So with a rotation, right, we don't just move things. That's not a rotation, right? We don't, obviously this is a rotation, right? So what things have been rotated? Which 2 cards show something that's rotated? You in the front. I'm kidding. If I was to take a guess, I would say number 1 and number 4, right? Because in this position here, number 1 is laying flat, and in number 4, it is standing up. I don't know about y'all's, but that looks like a rotation to me. So we've got a rotation. Which pair of cards show a reflection, all right, for B? Oh my gosh, this one's kind of hard, right? If you answered 5 and 3, you'd be absolutely correct. If we look closer at them, if I try to trace this image of 5, which is going to be a terrible, terrible tracing job, I do my best, right? Now, we don't have a line of reflection here, but that doesn't mean that it's not a reflection. I mean, we could imagine the line of reflection there. It makes it a little more clear to see that this is a reflection. All right, the longer end of this shape is on the same side, so that indicates a reflection. We're good to go there, all right? And then let's look at the last one. Well, the last one is C, and it asks us, oh, hello. I guess there isn't a C. Well, either way, these boxes 2 and 6 show us another kind of transformation called a translation, okay? Perfect. All right, let's move on to number 2. All right, 5 frames show a shape's different positions. Now, it asks us to describe how the shape moves to get from its position in each frame to the next frame. Okay, if y'all are wondering what I'm looking at that thing just on here. If y'all stream, you know what I'm talking about. Okay, so it asks us, the 5 frames show a shape's different positions, describe how the shape moves. Okay, let's look at 1 and 2. So I could say, oh, from 1, look, it was there and now it's here. Oh, it moved. Okay, it slid. Yeah, it's true, but where did it slide to? Well, it slid to the right. Okay, and going one step forward, slid is a great word, but it's not the word I'm looking for, right? We're learning about transformations here, so we want to use that vocabulary. So it translated to the right. Ta-da! See, no missing information. I told you what kind of transformation it was. It was a translation and the direction to the right. Okay, ooh, to the right. All right. The next one, well, it looks like it kind of rotated and translated at the same time, right? I mean, I could see how it rotated. Maybe it, rotated to here. Maybe I did that thing. Maybe it went like, and then translated up. Okay, that would be 2 moves, right? That would be 2 moves. We can be more efficient than that. Okay, so instead of saying it rotated 180 degrees clockwise and then translated up, we could simply imagine that there is a line of reflection and just say that it reflected across this line of reflection. See, it looks like this little guy or gal is looking at themselves, right? In a mirror. And they got some spiky teeth or something. Anyway, sorry, I'm getting lost. So that one is a reflection from 2 to 3. Reflection across the line of reflection. All right, here from 3 to 4, we're doing a very similar thing as we did in the first one. We are now translating, is the word, to the left. Yes, to the left. Okay, and this last one is from 4 to 5 is very similar. Uh-oh, back here. Thank you. Goodness gracious. This last frame is very similar to 2 to 3, right? We just reflected across a line of reflection, right? That would get us here. So these 2 shapes are looking at each other again. See? They're little eyeballs. Cool. All right, great. And then the last question, let me erase all this stuff. Hope you all are following along, right? Well, you're supposed to be watching this video, but, flip through the pages in your book. All right. So number 3, by the way, I should say, all of the homework, you've been doing, y'all's are in 8th grade, you've been doing this a minute. Every assignment that I'll give you, every homework assignment I give you is also in the book, right? So this assignment's on page 3. There you go. Okay. So if you're wondering where we are, that's where we are. So the rectangle seen in frame 1 is rotated to a new position seen in frame 2. Aha! We can see that it did a thing. Okay, what kind of thing did it do? It was a rotation, right? That was the kind of transformation we just did. So if it's rotating, it looks pretty close to 40 degrees, right? If I look at the shape where it is now, this line, and if I draw that line over here as well, this angle we can kind of use to describe how much it rotated, right? So that angle is not 90 degrees, definitely not. So it's not C, it's not D, okay? 140 degrees, yeah, it could move, 40 degrees, this could make sense, right? If it was to rotate, let's see, if it was to rotate counterclockwise, in the opposite direction of the clock, that will give it to us, right? So 40 degrees counterclockwise. Now, what if we wanted to go clockwise, the other direction? So instead of being right here where this line is, we're going all the way around. So we're finishing the rest of that motion, right? So if we were to imagine, let's say, this box right here, that's so great. Oof, It's not my best box. It's okay. If we wanted to imagine that rotating all of this way, oh, it doesn't have to go the entire way. Okay, so if we rotate it here, we're going 40 degrees, right? So if we go the other way, well, we'd be going 140 degrees. Now, a good way to think of this is if you go the full 180 degrees to get this shape around, right? It's not 360 because it's a rectangle. We don't have to go the full 360, right? We've got to include that 40 degrees, right, in that we did to go the 180, right? So if we take away that original 40 degrees, well, 180 minus 40 is 140. So it's not only is it 40 degrees counterclockwise, it's also 140 degrees clockwise, right? So we just went the other way. That works as well. And that brings us to the end of the homework. Ta-da! All right, so hit submit on Canvas because I'm going to be grading these, okay? Make sure you're handing them in on time as well, okay? So by the time you leave my classroom today, that should be submitted. Okay, actually, it should be submitted like right now, whatever time it is. Okay, so let's go into the lesson. All right, page 22, 3.2 transformation information. This is, like I said, on page 22 after the starter. Okay, now I want y'all to take about 5 minutes to do this on your own, or with your desk partner, I should say. So the person to the right or left of you, sitting at your little desk partnership zone. I'm going to come up with a good word for it, but you're going to work with them on this. So be talking with them. Feel free to pause the video. In fact, please pause the video, okay, and work on that. So what you're going to be doing here is reading the instructions, okay, and answering those questions. You'll actually be drawing on here, and it asks you about reflections, rotations, transformations, translations, okay. So you'll be doing that for 1, 2, 3, and 4. Whoops. And 5, 6, 7, and 8. Now, 1 through 4, we've got a grid. 5 through 8, we've got a isometric grid. So we'll probably be looking for rotations of 60 degrees in there, okay? So go ahead and do that. Pause the video and give it a go. See if you can get them right, okay? And I'll wait here for you to finish it. Just kidding. I'm going to start now because I'm paused right now, so you can't even hear me. Oh, no. But then you're going to push play. All right, so you have now hit play again. Welcome back to the video. Hope that was exhilarating. Okay, now in figure 1, it tells us to translate the triangle ABC so that A goes to A prime. Okay, this is fantastic. It didn't give us a direction to translate, which is fine. They did something better. All right, they told us to translate the whole triangle so that A, right over there, goes to A prime. And this is the best. I love it when they do this. It's so, simple. You take your triangle and you simply translate it so that A is where A prime is. Ta-da! And that means that B will become B prime and C will become C prime. Ta-da! So those little, you see a letter with a little ch right there? That little ch is called a prime, right? So this is A prime, this is C prime. We've got B prime down there, and things can get crazy too. You do a bunch of different moves here, you can end up with a double prime or a triple prime. And we're not going to go farther than triple primes. That's even triple primes we won't deal with too much. This stuff's crazy. Okay, so that's what you should have for figure 1. Okay? Figure 2, same thing. All right, figure 2 is asking us translate triangle. Well, we're translating, right? Triangle ABC so that C goes to C prime. Brilliant. Okay, so this one's even better. It's an even simpler move. Right, so we're taking C to C prime. Look at that. That's fantastic. We did it. All right, so if you have this for figure 2, great. If you got figure 2 and figure 1 correct, you're feeling solid about translations, which is good. Okay, that's great. Just reflections and rotations to go. So with rotations, we do need a bit more information. Okay, translations are great. We just tell us, okay, it's a translation, what's the shape, what goes to what, or how far in what direction. Okay, with rotations, like it says here in figure 3, it tells us to rotate. Great, it's telling us what type of transformation. The triangle ABC. 90 degrees is how far we're rotating, and then counterclockwise is the direction. Okay, but what do we rotate it around? Well, we're using center O. Okay, so we have all of our information. We're rotating something. We're rotating ABC. We're rotating it 90 degrees, and we're rotating it counterclockwise. So opposite the way the clock goes on the wall, which for me is there. It's above the door. You can see it. If you can't see it, stand up and take a look at it. Okay. So number 3, I'll go over kind of how we did that, or how I did that. Okay, so I'm rotating it around O, and it's 90 degrees. Oh boy. And it's counterclockwise. So counterclockwise means everything's going in this direction, right? Okay, so we're going 90 degrees around O. So what I often will do here is I'll find a line that links up with the center of rotation. You see how this line, O to B, well, from C to B, if I just extend it, I get to the center of rotation. Fantastic, right? Now, if I rotate that, I'm going to leave that extended there. Okay, I'm going to make a new line. Now, if I rotate that so that it makes a 90-degree angle with the original line, I know I've rotated 90 degrees. Fantastic. Okay, I've got a 90-degree rotation. Just that line, though. Okay, the rest of them, it gets kind of tricky, right? So if I actually were to make this line proper, right? Like that, okay? Now I've got to remember where the rest of the lines go, right? So this line here, this blue one that I made purple, from A to C, that line, same thing, should be rotated 90 degrees, okay? So you see how it kind of goes from point C, because we know C prime's here, right? From point C, this line goes over to the left 4 and down 1, right? Well, that's been rotated 90 degrees. So instead of going to the left, that 90-degree rotation is now going down. So our new line is going to go down 4 and to the right 1. And that makes it quite a bit easier to create that rotated line. And even looks a bit better, right? We can kind of see that. All right, if it doesn't look right, you've done it wrong, okay? So if you look at something and you're like, that doesn't quite look well, it's wrong. And, if it doesn't look right, chances are it's not right, okay? Now, from A to B, we're just connecting these 2 dots, and voila, you have a perfect rotation. Oh my gosh, so crisp. All right, so fantastic. That is what it looks like, okay? And again, if you're not so sure about your rotation, right, you can always double check it, right? Use that patty paper or that wax paper, okay? See, we've got that line there. We rotate it 90 degrees. That line should be rotated 90 degrees, and it is. Why is this coming out? Oh, because it's there. Oh, no, I just messed this up. You should be there. There it is. So much better. Okay, great. If your line looks like that, fantastic. All right, let's do figure 4. Okay, so this is a reflection, which is so marvelous. Okay, how's my battery doing? 18%? Hang on a second. So with figure 4, we're reflecting around line L, that line of reflection. Okay, so if we take a look at this line of reflection, okay, these are really simple to do because look at point C. Okay, you see how it's 1 unit away from that line of reflection? All right, well, that means C prime is going to be just 1 unit away in the opposite direction from that line of reflection. So to get to C, sorry, not C prime, we're going from the line of reflection to the left, right? In order to get to C prime, the reflected point, we have to go in the exact opposite direction. Okay, exact opposite direction. It doesn't do enough to just be on the other side of the line. Okay, C prime is not going to end up there. You have to be going exactly across the line of reflection, perpendicular to it. Okay, what does perpendicular mean? I wish I could ask you this in person right now. Oh, it means it intersects at a 90-degree angle. Okay, make sure that is the biggest mistake people make. Sometimes with these things, they'll be like, okay, so to the line of reflection, and for whatever reason, they'll do this. I don't know why. I don't know, but they'll do it. Okay, the next one I'll show you. It's kind of, people get mixed up with it. Okay, so we do that for C. We do the same thing for B. B prime will be here, and the same thing for A. It's 5 units away, so we go 5 units this way, and we get A prime there. We link those all together like so. Oh my goodness, how beautiful is that? We have our reflected image. Okay. Ta-da. All right, you can see down there it does say reflections are pretty simple. It says reflect the triangle using line L. It will give you a line of reflection and tell you to reflect that. Only 2 bits of information, which is kind of nice. Okay, if you haven't done the last 4 yet, give it a go. Okay. All right, and then, pause the video. You're going to be working on it. I'm going to be here, so I'm sure at this point you've unpaused the video. All right, now this one, I'm only going to do a couple of these because for time's sake. I want you to have enough time to do them as well as, finish all this work in class, watch this whole video, which hopefully is not too long. We got an hour-long class. How long have I been recording so far? 22 minutes? Good luck. All right, well, we'll be good. So in figure 5, let's look at figure 5. It says rotate quadrilateral. Let's do this. Let's underline it. Rotate ABCD 60 degrees counterclockwise using center B. All right, fantastic. This one's actually not bad. So the key thing about this is it says 60 degrees, which would be a problem if we were using grid, like a regular 90-degree square grid. But we're not. We're using isometric grids. So this just got a lot easier, all right, because we know that the isometric grid is made up of triangles that are equilateral. So all of the angles on those triangles are 60 degrees, okay? So any line we take, like for example, this line, okay? If I rotate this line around that center point that you can see, right? If I line it up on one of the lines and rotate it till I get to another line, like this, see how it's laying perfectly flat on a line? The degree measure from here to here is going to be 60 degrees, right? And you can see that because those line up on a triangle right here. That's 60 degrees. Okay, so we're going to do the same thing here. Okay, I usually start with one line. Okay, so our center is B, which means B is not going to move. The center of rotation doesn't move. So if your center of rotation is a point on your figure, great news. That's one less point you got to move. So let's check this out. So we've got line A to B. It lines up with B. It lines up perfectly on one of these flat grid lines. I like that because it makes it easy to see how far 60 degrees is. So if we go 60 degrees, should be right there. Let's check it. Oh, yep. That's in line with the triangle, so we are good. Perfect. Now the rest comes, okay, which you can kind of follow the rest from the other picture. Like, oh, okay, so I'm going to twist this. I'm going to orient it a bit. Okay, great. So that did a 60-degree move. Let's make B to C do a 60-degree move. Okay, that looks like the corresponding angle on the ABCD, so we're good there. Okay, and then I noticed D to C, that's a bit farther away, that's a bit tough, but if I look at where my C prime is and where my D prime should be, well, it's 2 of the bases of those triangles away. So it's 2 of these bases away. And that'll be where D prime is. And then to get from A prime to D prime, well, we just connect these because they're connected over here. So for these, you're using the grid to help you out, but you're also using, I guess, the original figure as well. I really only use the grid for one of the lines, that first line right here, B to A prime, right? The rest of them, I kind of look at our shape and, well, I just see what makes sense there, okay? If you can't see what makes sense, there's no worries there, okay? What I would recommend doing there is using the patty paper, right? Drawing your whole shape on the patty paper. And then actually, I'm going to use a different color for that. Drawing your whole shape on that patty paper or see-through paper, and then just focus on line AB, okay? So that when you rotate it, if we're using the patty paper, the rest of the shape will go with it, okay? All right, so that was a rotation. I did want to show y'all that because it's cool. But we're going to skip ahead to figure 7, okay? So I don't know if y'all remember what I told you about reflections, right? We go directly across the line, same distance. Okay, so here for 7, we are reflecting quadrilateral ABCD using line L. So we see quadrilateral ABCD here. We see line L, that's this one. All right, great, let's do some reflections. So a lot of what people do here is this. Okay, this is incorrect. If you did this, don't worry about it. We got time. Okay, but listen to this, okay? So I have a lot of people do this. Okay, so we stay along the grid lines. I want to stay along the grid lines. They're safe. They make me feel warm inside. So it's 1 unit from D to the line of reflection L. Great, I'll go 1 more unit. And we've got D prime. Okay, I'll do the same thing for C. 1 to the line of reflection, 1 past, that's C prime. Okay, so I've got those 2 points. And then B prime would be 2 across again. So we've got B prime, and then A prime was 2 across and 2 again. So we've got A prime. Okay, great. Awesome. That's fantastic, right? Okay, wrong. It's not fantastic. Okay, look at this. Look at how far B is away from the rest of them. In fact, A's not even in the right place. Okay? Even if you did those correctly and just figured out, okay, I know that A prime actually should probably be here and B prime should actually be right there, right? Okay, so that looks more like our shape, right? Is it a reflection? No, it's not, okay? These points are not intersecting the line of reflection at a 90-degree angle. They're not perpendicular. They're, well, that's an obtuse angle, okay? So it's not 90 degrees. So you have to remember, especially on isometric grid paper. Okay, I'm going to move this. Whoops. So I guess I'm just going to erase all this. I'll put my points over here. Put the points over far away. So with A, or let's start with D, right? D, it's got to intersect perpendicular to the line. See how this blue line I made is a right angle? Okay. Same with C. That blue line's a right angle. Same with B, we go 2 to the line, we intersect it at a perpendicular, well, at a 90-degree angle. We get that. Okay, let's do the same thing with A. Still a 90-degree angle, fantastic. So now I'll do it in purple because purple's just the best color. If you don't agree, that's fine, we just won't get along. I'm kidding. You can not like purple, it's okay. But anyway, see, look at that. We've got our line, we've got our A prime, our D prime, our B prime, and our C prime. I don't know why I included those other ones. We can say goodbye to those points. Now, this looks right. This looks like a much better reflection, okay? We can see here that if ABCD is looking at themselves through the mirror, right, they're going to see A prime, B prime, D prime, C prime. Okay? If you have trouble with this, it often helps standing, like rotating this screen so that the line is straight up. Y'all can maybe see that here. Okay? Let me move it closer. See how that line's straight up now? We can kind of tell a bit better that these are a reflection. So if you need to rotate the page, do it. Don't worry about rotating the page. Absolutely do it. Okay, so let's see. All right, we're not going to go over figure 8 because it's a translation. Oh, we want to do it so that A goes to C? Let's do that real quick, okay? So if I'm translating so that A goes to C, look at this. Look at this. This is going to be great. All right, we're just going to do this. Simple enough, right? You can do that on your patty paper. It's great. Okay, awesome. So let's go to, what else is it? The lesson 3 summary. Okay, now this is something I want y'all to read on your own. If you'd like to read it, I'll go through it right now. That's totally fine. You can watch this part of the video if you want to. If you'd rather read it on your own, that's fine. You can do that. But at least like mute the video and maybe see what I highlight, because I will highlight some important things. But if you have good highlighting skills, you know how to read a text and get the important stuff out, send it. Okay? So here's the lesson 3 summary. When a figure is on a grid, we can use the grid to describe a transformation. For example, here's a figure and an image of a figure after a move. So we can see figure A, B, C, D, and A prime, B prime, C prime, D prime. Okay? If you know what kind of move that is already, great. Okay? Fantastic. If you don't, let's read on. All right, quadrilateral ABCD is translated 4 units to the right and 3 units down to the position of quadrilateral AB, A prime, B prime, C prime, D prime. Okay, fantastic. All right, so that's just telling us the move. Pretty much what they've done here is key thing, 4 units to the right and 3 units down, right? So A had to go 4 units to the right and then 3 units down to get where A prime is. If we can identify that, that'll come in really handy later. We don't always say A goes to A prime because sometimes we don't know where A prime is. But the best way to identify a translation is to, if a shape has gone diagonally, like, from here to here, instead of from like here to here, if it's gone diagonally, on a grid, we can't really express a diagonal movement super well. We can express a horizontal movement and a vertical movement very well, though. So we use that. Okay, well, we can say, it moved 4 units to the right and 3 units down. Perfect. Instead of saying, it went diagonally like some number of units. I don't know what that distance is. I could calculate it, and you will be able to too, but not yet. Okay, that's that bit. Great. A second type of grid is called an isometric grid. This grid is made up of equilateral triangles. See, we already knew that. The angles in the triangles all measure 60 degrees, making the isometric grid convenient for showing rotations of 60 degrees. Ta-da! Okay, here's quadrilateral KLMN and its image K prime, L prime, M prime, N prime. This is hard to say. After a 60-degree counterclockwise rotation around point P. Okay, so we can see here kind of what they did. Well, if you're ever curious about it, it helps to extend some of those lines. See how line LK points directly to point P, and so does L prime K prime. Okay, we can see the distance there is along that triangle, so that's 60 degrees of movement. Beautiful, fantastic. Okay, great. So that's kind of the ticket. All right, the rest of those followed. Now, that's it. There's a synthesis. Okay, what I want y'all to do on this unit, this will be on page, it isn't. It isn't on a page. This is just part of the video. So this is your exit ticket to leave today. Okay, so what you have to do is tell your sub, okay, your substitute teacher, all right, before you leave, which of the triangles is a translation of triangle A. And this might be a discussion y'all have at the end of class. Okay, so triangle A being this one. Which of the other triangles is a translation of triangle A? Not a rotation, not a reflection, but a translation. And I also want y'all to discuss, especially with your desk partner while you're doing this, how do you know it's a translation? How do you know it's not a rotation or a reflection or anything like that? Okay? Do that. Talk with each other. When you've got that down, When you think you have the answer, either go talk to the sub or talk to somebody else. Let's say talk to your other desk partners. Do that. Talk to the group of people that are either behind or in front of you. See if they got the same thing. Okay? Cool deal. And then you'll have a whole class discussion. It'll be great. This video is now 35 minutes long. I hope you've had enough time to work on other things. And if you got all this done and you have more time in class, you can go ahead and start on the homework for tonight, okay, which will be the lesson 3 practice problems, which start on page 26. Now you can either do these in your workbook or on Canvas. I obviously always recommend doing them in your workbook first because sometimes Canvas doesn't have the pictures and the pictures will always be in your workbook. Okay, so you should always be doing the homework. Even if you're doing it on Canvas, you should always be doing it with your workbook open in front of you. All right, sweet. Well, hope that was a fun lesson. Hope y'all had a good time. Hope y'all learned something, but I will see you in the next video tomorrow. Okay? Take it easy. Bye. Oh, I got to pause this thing now too. See ya.